I am Taya Blad. I'm a master's student. I am just about to start my second year. And I would like to start off by saying how privileged I feel that I have been able to be here learning in this beautiful state because there is not much published data for our state. So it's been a really good chance to be able to work with producers and see a difference hands-on. So for people outside of livestock production, really seems like all we care about is growing our animals as fast as we possibly can. Growth, specifically efficient skeletal muscle growth, is really important to our producers, as you all know. An animal's weight at weaning actually impacts how that animal will go on to grow throughout the rest of its life. And a higher carcass weight, like Dr. Reichart Caleb was talking about, it provides a higher paycheck and even more cuts of meat per animal. So it becomes really important for us to care about what our animals weigh. Skeletal muscle is made up of bundles upon bundles inside of other bundles. So we have these myofibrils here, and we have groups of those myofibrils, and then they make up muscle fibers. Groups of muscle fibers make up muscle fascicles, followed by skeletal muscle. Skeletal muscle grows differently before and after you're born. Before you're born, it grows through what is known as hyperplasia. And this is similar for all mammals. Hyperplasia is when these skeletal muscle fibers are multiplying in number. We're getting more. However, at the time that mammals are born, muscle fiber number becomes fixed and only hypertrophy occurs, unless in extreme circumstances. So hypertrophy is when those individual muscle fibers are getting larger. Myofibers, or the skeletal muscle cells, cannot self-replicate. So if they can only grow in size, how are we growing them? To be able to increase this coverage, they have a limited, right, let me take a step back. These cells have a limited area of coverage. They can only reach so far and impact this area. So we have to rely on these satellite cells, which are basically skeletal muscle stem cells. And we rely on them to be recruited and fused to these cells, or to these fibers, increase this overall coverage they're able to reach. Satellite cells, until they're needed, are kind of in a sleeping state. It's known as quiescent. And then if our animals go out and run, or they trip and have a small muscle tear, this can activate them to exit out of that sleeping state and re-enter back into our cell cycle. And they'll start to replicate. Throughout that, there will be a few of them that'll go back to replenish the satellite pool, so that next time we need them, we have some available to be able to be called on again. But those that stay in this process, they start to go through this differentiation where the cells start to change shape and they will elongate and eventually fuse into these existing muscle fibers. And that's how they're able to provide that potential for growth. But it's really important to say that having these fused satellite cells doesn't mean your animals are going to be having increased skeletal muscle growth. Growth happens when more protein is being produced and then broken down. And so hormones, growth factors, a lot of components go into inducing this higher rate of protein synthesis. Satellite cells produce some of those components that are involved. So this myonuclear accretion, which is the process of gaining those fused satellite cells, provides the potential for more hypertrophy. It means that it is possible to be able to grow. Doesn't mean that it's happening, but that it is able to happen. A lot of factors go into efficient skeletal muscle growth, including nutrition, genetics, and how we manage our animals. Why do I keep emphasizing efficient? We want our animals to be able to produce more muscle and less fat, but still have enough fat for a quality product because there is that taste factor and texture that goes into the final meat product. There's a balance between growth, energy. And so we have to find that balance because if we want our animals to grow quickly, we're going to have to feed them more. But if we provide too much energy in their diet, it's going to cause that excess energy to be stored as fat. And we're going to have more fat laid down than we are wanting. So how do we find that balance? The National Research Council, known as the NRC, publishes nutritional requirements for livestock. The last small ruminant that was published was in 2007, so they don't do this all the time. But even when they republish them, there's usually very few things that change. So you can reach out to your extension agent and they are able to help you find some of these requirements if you're not able to figure them out or if you don't have access to them. So nutritionists use these requirements to help determine a balanced ration. So with a mixed feed, that'll be balanced to figure out what our animals most likely need. They're not going to be just throwing micronutrients like copper or selenium in amounts that doesn't make sense for our animals to be healthy. So it's going to be formulated to fit those requirements as closely as possible. Although having these fused satellite cells is necessary for the skeletal muscle growth, if we aren't feeding our animals the nutrients that they need, they aren't going to grow like they have that potential to. Let me try saying it a different way. You have a cake recipe that's a pretty basic cup of sugar, half a cup of butter, 2 eggs, a teaspoon of vanilla, cup and a half of flour, some baking powder, and half a cup of milk. But you only have 1 egg. This means you can only use half of your ingredients to make a cake the half of the size of your original recipe. This idea is known as Liebig's Law of Minimums. If we aren't fulfilling our animals' requirements, they aren't able to be as productive as they could be. If we have a barrel that has a leaky spot, we can only fill that barrel to where that spot leaks. It's not able to be full above that because it'll keep leaking. And the same thing is with our animals. If they don't have enough nutrients to fulfill all of these requirements for growth, they won't grow as well as we want them to be. Like Dr. Page mentioned, there are these 6 classes of nutrients. Carbohydrates, proteins, and fats are all used for energy. But like if you only have 1 egg for your cake, not feeding enough of any one class is going to limit your growth, especially for those that are providing your energy. But what does this look like in real life? Because I can throw theory at you, but it may not make sense. If you're not feeding enough protein, this can lead to conception and abortion issues. Our animals may eat less feed, which will slow down their growth, and that leads to that slower rate of growth, and they're unable to use their feed as efficiently as we want them to. This could also affect our mothers being able to produce less milk, and there's a process that during pregnancy, if we're not feeding our mothers enough protein or other things, it can lead to a process known as fetal reprogramming, which means it actually will affect how the offspring grow throughout their lives, because it is kind of set in it's kind of warning the fetus that when they get out into the world, they may struggle with nutrients, so they need to be more efficient. And since this skeletal muscle fiber in mammals is fixed at birth, our maternal nutrition, especially during pregnancy, is so very important. Skeletal muscle growth really happens in 2 waves. Sheep are pregnant for 5 months, And so if we separate this out into trimesters, myogenesis, or the process of muscle growth, happens mostly during these first 2 trimesters. And it's not just muscle growth, but this is when these fibers are increasing in number. So this is the hyperplasia. If we restrict nutrients during this time frame, it can result in a lower number of muscle fibers and a lower birth weight. If we have less fibers to start with, it's going to be harder for these animals to grow bigger. However, even during this last trimester, hypertrophy, where the fibers are growing in size, is starting to occur. And so nutrient restriction here can lead to a lower birth rate or birth weight. And again, we want to have our animals at a good size when they're born to set them in on their own feet to be able to grow for the rest of their lives. On the other end, though, if we overfeed our mothers, it can cause dystocia or difficult birth and a lower production in the mother. And it can also lower our birth weight and growth rate of offspring. So we really have to make sure we're trying to stay as closely as possible within that ideal balance, because either way can end up affecting our production. Breed also affects skeletal muscle growth. There are 4 types of muscle fiber composition, and they're used for different things. Some breeds may have more type 1 fibers or slow. These guys contract slowly and will go for a duration of hours. So endurance runners, these are the type of muscles that is being used then, versus this type 2B, which are very fast. These fibers are contracting quickly, under a minute, but they don't last long. So they're used for sprinting, this short burst. And so depending on different breeds have different ideals of what they're known best for. And so that can affect. And so as we have these crosses, it can bring a combination of everything. But it's important to say that can affect, it can affect how they grow. Breeds also affect what genes may be expressed, as well as the growth rate and maturity age of our animals. It can affect how hormones are regulated, and even how well our animals are able to convert their feed. And it's really important to mention that we don't get much data for either sheep or goats. Most, if not all, of our information is coming from the 4-H program. And so we don't have much. A lot of these projects are very similar to the first of their kind, so we're able to focus on Hawaii to get a little bit more information about what's going on in our state. How does my research apply to any of this? I'm studying the effects of increasing concentrations of vitamin C or vitamin E on sheep satellite cell proliferation rates and protein synthesis rate. So I'm seeing if I treat cells with this vitamin C or vitamin E, is it making them grow faster, making more of themselves faster? Or does it affect how fast protein is able to be synthesized? A lot about vitamins isn't understood. National Research Council, the NRC, provides those guidelines to prevent deficiency and toxicity for most vitamins. But the ideal concentration for our optimal skeletal muscle growth, that's unknown. To throw an extra twist, ruminants are actually able to make their own vitamin C because of their rumen. They are able to synthesize it there after about 6 months of age, unless they're in times of great stress. This means there are no minimum requirements for vitamin C. Overall, we don't supplement vitamin C, but maybe we should be. We don't know if there's an optimal level. But why do you as producers care about my project or any of these things? Importing vitamins and minerals is a huge cost. It's hard to access, as we've talked about and seen today. By testing these different increasing concentrations can help us start to identify these optimal concentrations. So my project itself is focused on cell culture work, so I'm doing in-lab work. And that sets the groundwork for us to then be able to go out and test these concentrations that we determine are good, like are most optimal, to then go out and test those on a herd of animals to see how it affects them. But even if we figure out that increasing concentrations don't have any effect on the satellite cells, it still can teach us, because if we can feed minimums and still maintain the same level of growth, why would we feed more than we need to, especially when it costs so much and is hard to access? So to recap, skeletal muscle growth is affected by nutrition, genetics, and the management of our animals. Skeletal muscle development happens both before and after birth. So we need to make sure that our animals are having adequate nutrition during pregnancy, lactation, and throughout their lifetime. And finally, we wouldn't be able to complete our research without the help of our producers and these relationships we've been able to build. So thank you for that. Any questions? And if you have any others that are more complicated, or if I've just confused you with all these technical things, feel free to reach out to me at my email. I am more than happy to talk about my project.